Howdy, this is MMET 370 lab number 6. It is a heat transfer experiment. In this, I'm going to briefly discuss about the setup we have, and then later we'll see the physical devices and how we conduct the experiment. So this is a schematic diagram of the experimental setup. In this, we have 4 different thermocouples, and we also have one heat flux sensor which is attached just beneath of the concrete slab. We have this light source here. It's a halogen lamp which acts as a heat source. When we turn on the light, it will transmit that heat energy and it will pass through the concrete slab from top to the bottom. And in doing so, we can capture the temperatures from TC1, TC2, TC3 and TC4. And also we're going to capture the heat flux passing through the concrete slab with the help of heat flux sensor. The key element of this experiment is that the student can access the experiment and they can also access the data remotely while sitting at their places in their rooms or in the libraries. So in this experiment, when we turn on the lights, we'll acquire all the temperature readings from thermocouple and also the heat flux reading from the sensor with the help of NI DAC. And this NI DAC is connected to a local server laptop we have in the near the workstation. So it will acquire that result, and that LabVIEW code is compatible with the ThinkSpeak platform, so it will help us to broadcast the signal to the internet cloud, and through that data is going to transfer to a remote server, so through which the students can access these results and they can also see the experiments in real time remotely. As I mentioned before, during this experiment we're going to measure all the temperatures from TC1 to TC4, and we're also measuring the heat flux with respect to time. This data will help us to measure the heat transfer coefficient, that is U, and the thermal conductivity K of the concrete slab in the steady state regime. On the experiment day, we'll decide the date and time. Will inform the students to access this link on that particular given time frame, because during that time we'll start the experiment in the lab. Using this link, they can access the data in real time, and at the end, at the completion of this experiment, they can also download the data, the required data in the CSV format, so they can use that for further the data analysis part. Howdy again, Digvijay here, and also behind the camera Devin is helping me to shoot this video. So over here we have the setup for lab number 6, that is our heat transfer experiment. Okay, so if you can come close, we have this halogen lamp that acts as a heat source over here, so it's already on. As you can see over here, we have this concrete slab which is our experimental workpiece and which is embedded with different thermocouples. So my TC1 over here is measuring the ambient air temperature on the top. My TC2 is this one, which is measuring the top surface temperature of this concrete slab. In the same fashion, I have TC4, which is measuring the slab temperature at the bottom surface, and my TC4 is measuring the ambient air temperature beneath the surface. Apart from that, I also have a heat flux sensor which is attached at the bottom of this concrete slab, which will help me to measure how much heat flux is flowing in the real time. Okay, and all this instrumentation is connected to a NI DAC over here, and this NI DAC is connected to a LabVIEW program through this server laptop over here. So let me just start that, but before starting that, I need to copy my ThinkSpeak API key. So if you come over here, this is my API key. I need to copy this API key. This is very critical step over here, because this will help me to transfer my data to the remote access student. So I will just paste it here, and then I will run my program, and you will see my program is started running and my temperature is been recorded along with the heat flux. Okay, so let's come on to the view what student is seeing in that remote access thing. So as you can see, we have this view which is being viewed by every remote access student. So as you can see, I am capturing my all thermocouples temperature reading over here along with the heat flux sensors, and as you can see, my data has been modified in real time as the time is progressed. So you see, I can see three different readings on the plot for now, but if you wait for more time, we'll see more and more reading is coming up because we are capturing it in real time. So that's the essence of this experiment, through which the student can access this data remotely and they can see the same channel on their laptops, on their phones, or on their tablets. So that's all. So this experiment is going to run for at least 2 hours to make sure we have a good enough steady situation, and at the end of the experiment we'll close this light and we'll turn off the program so students know we have stopped the experiment. So yeah, that's all from today. See you in the next video.